Hey folks, welcome back. In this session, we'll clearly understand what exactly is a JK flip-flop and how do we implement it with Verilog. The last sessions we have understood about the D flip-flop, the T flip-flop and then SR flip-flops. I hope you liked it, and the SR flip-flop is very similar to what we are going to learn right now, and we will understand how exactly JK is different or similar to SR flip-flop. This is same as SR flip-flop. Theoretically speaking, SR and JK are the same. There is a very minor difference that we need to understand. When both S and R inputs are high, the output is indeterminate or it is non-existent in the case of SR flip-flop. But when you go ahead with PLC or other programming environments or infrastructure, it is definitely required to assign a deterministic output to all the conditions of the flip-flop. It cannot say that I do not have an output. It must have an output. So in that case, RS flip-flop or SR flip-flops cannot be used, and we need to go ahead with a change. The change is nothing but the JK. The J and K are nothing but the Jack and Kilby. The Jack Kilby is the person who designed this, who is the brain of this flip-flop, and there is a minor change from the SR or RS flip-flop to the JK flip-flop that we are going to understand right now. There are three inputs again, the J, the K and the clock. There are two outputs which are nothing but Q and Q bar. That's very simple. Remember one point, I keep repeating this every time when I talk about a flip-flop. Whenever a clock is zero, which means whenever the clock is not set or in the rising edge, the flip-flop cannot do much and it will just act as a wire. Remember, only when the clock is set to 1, only when the clock is in its rising edge, it can give you some real meaningful output and it will work as a flip-flop only then. And remember, the J is equivalent to S here, K is equivalent to reset here, and set reset is what we have learned with SR flip-flop or RS flip-flop, or we have learned that in the previous session. And here it is going to be J and K inputs. J can be remembered as S, which is set. K can be remembered as reset, which has to be seen and realized with the truth table right now. The first condition that we are going to see is when the clock is 0. Assume the previous state as 1. We assume the previous state as 1 and the clock is 0 right now. And just close your eyes and listen to me whatever I say now. Whenever the clock is 0, whenever the clock is 0, irrespective of whatever be the value for J or K, it will retain the previous state as the output. Whatever be the previous state will remain as the output when the clock is 0. Remember it, and that's what is reflected in the table. The clock is 0, J is 0, K is 0, it retains the previous state 1. Clock is 0, J0, K1, previous state. Clock 0, J1, K0, previous state. Clock 0, J1, K1, previous state. That's it. Just close your eyes and that would be the previous state whenever the clock is remaining 0. This is a rule and remember it. Now, when the clock is 1, this is where the real function starts. This is where the real game begins. Now, whenever the clock is 1, what will happen? The clock is 1 here. J is 0. J is 0 and K is 0. This is K. We'll have to correct it. J is 0 and K is 0. It will retain the previous state because we have not got any task assigned here, which means J is also not set and K is also not set. Hence, this is going to retain the previous value. Remember. Now, if you see the next case, clock is 1, J is 0 and K is 1. K is 1. K means a reset. So whatever be the previous state, I get it a reset here. The clock is 1 and reset field is enabled. So it is reset and Q bar is 1. Reset to Q bar, it will get you 1 there. And clock is 1 and J is 1 and K is 0, which means it is set. So I will have a set result here. 1 is available here and 1 bar is 0. Finally, when I have 1 1 for both J and K and clock being 1, it will toggle the previously available state. So this will be toggled and this will be 0 here and 0 bar will be 1 here. This is the only change that you have from the RS flip-flop to the JK flip-flop. In the RS flip-flop or SR flip-flop we have seen, this will be a non-deterministic state. This won't be there. We'll say that it is non-existent, but here it will toggle the previous state value. That's it. That's the only difference that you have. Can we go ahead and code it right now? It's time for us to code. The same code, there are no major changes, but the only thing that we need to understand is we'll go through it and then understand how exactly some minor changes are carried out with respect to JK flip-flop from the SR1. I've started the code here. It's a simple module, and you can see that I've got input J and K and clock. Output is Q and Q bar. The output has to be registered, so Q and Q bar, it has to be stored. Hence I make it a register, and the initial state is assumed as 1 and 1 bar is 0. Now always at the positive edge of the clock, always at the positive edge, I begin the code and I go inside. J is 0 and K is 0. What will happen? J and K both are 0, it will retain the previous state. When J is 0 and K is 1, what will happen? It will reset. I'm going to reset it. K is set as 1, so I will reset it. Now when J is 1 and K is 0, it will set it. When J and K both are 1, I will negate the previous state and I will get the complement. That's it. The same is the case here for the test bench that we have written, and I'm going to go through it quickly. I've got the module written, I've created an instance properly, I declared something as wire which we need, and I declared rest of the things as register as required, and inside that begin module I have display and monitor. Monitor will help you in monitoring even the minute of the changes that happens with respect to the fields that we have mentioned here: J, K, clock, T underscore Q, T underscore QB, Q and Q bar. Whenever there is change in any of these, we'll get it reflected in the output, and that's it. Let's go ahead with understanding what are all the input fields. Clock is 0, J is 0, K is 0. Clock 0, J 0, K 0. When clock is 0, what will happen? Irrespective of whatever be this, it should retain the previous state. Now, clock is 1, K is 1, and you can say, sorry, clock is 1, J is 1, K is 1. So what will happen? It was non-existent in the previous scenario with SR flip-flop, but in this case what we will do? We are going to negate the previously available output. So the previous state output will be negated here. Now the next case, J is 0, K is 1 and clock is 0. So when clock is 0, close your eyes and declare that it will retain the content of the previous state. Now clock is 1, J 0, K 1. It will reset. Set, reset. You remember it, K is going to reset it. Similarly, the last couple of options, clock is 0, J and K respectively 1 and 0. So it will retain the previous state. Clock is 1 and J is 1 and K is 0. When J gets to 1, it will get set. That's all, and we have got the output here. We can go through it once again to get your understanding better. J, K and clock, all these are 0. When clock is 0, Q will be the previous state. As per our code, whatever we have given here, Q is set to 1 and that's our initial state. So it will be retained properly and 1 bar is 0. Now all ones here, this was non-existent in the previous scenario, but here it will be a complement. So you can see that here the previous state is complemented. Now clock is 0. So irrespective of whatever be these values, don't worry, retain the previous state. Clock is 1 with J being 0 and K being 1. So it is reset. So it is 0 again. Now clock is 0, don't worry, reset. Don't worry, retain the previous value. Now clock is 1, J is 1, so it will be set while K is 0. That's it. We have implemented it. Can you see the output? We need to see the output screen right now so that you will understand that this works fine. I'm going to run it right now for you and we will get it neat. I have compiled it. Now we will run this JKF. Yes, we got the output. That's it. It's very simple and I hope you understood it. If you have any queries on this, please go ahead and type it in the comment section. I'll be able to help you happily. And if you like the channel and the content, please give a thumbs up and subscribe. Thank you very much.